FTC DECODE places such a strong emphasis on precise localization. To score consistently and recover quickly after collisions, a team must have accurate knowledge of its position on the field at all times. So, what our team did to solve this challenge was to use a hybrid localization system that combines relative and absolute localization. Relative localization estimates the robot's position based on its previous one, and usually this is done with odometry and an IMU. So relative localization is fast, responsive, and accurate over short distances, but since small errors accumulate over time, the robot's position will drift away from its true position. Meanwhile, absolute localization uses a fixed element on the field to determine the robot's position. And this is usually slower than odometry-based tracking, but it does not accumulate drift and thus can always be used to correct the robot's position estimate. By combining these two approaches, we get the best of both worlds, basically. The responsiveness of odometry and the long-term accuracy of vision-based relocalization. In today's video, I'll walk through how we implemented Limelight AprilTag relocalization integrated into pedropathing. Here's an overview of how we perform our relocalization. In relative mode, the follower simply updates every loop using odometry and pinpoint IMU. However, the driver can trigger the absolute follower state in which the regular follower update is interrupted in order for Limelight poses to be collected and averaged, processed in our custom Pedro localizer method, and returned to the follower to reset the pose. So the first step was selecting an appropriate mounting location for the Limelight. And we could have mounted the camera on our turret, and initially we were thinking of doing this because the camera could remain pointed towards any AprilTag, no matter the robot's rotation. However, this is not appropriate for relocalization. This is because of several challenges. The turret will add another degree of freedom that must be tracked and calibrated accurately. Also, flywheel vibrations and turret movement will introduce more noise into our vision measurements. And finally, this would just be a little bit harder to wire with the rest of our system. Our primary goal was accurate relocalization instead of target tracking, so we chose to mount the Limelight rigidly to the chassis. Another choice we had to make was between two AprilTag localization algorithms, Megatag 1 or Megatag 2. And Limelight's Megatag 1 provides a complete pose estimate directly from the AprilTag, which includes both position and heading. Meanwhile, Megatag 2 requires the robot's heading from, say, the IMU to constrain the solution and provide a more accurate position. However, we decided to use Megatag 1 because we wanted our vision to basically be a fully independent source of robot location information. Essentially, what we wanted was when we detected an AprilTag, that would give us a complete estimate of the robot's position on the field without depending on another localization subsystem. Of course, Megatag 1 is more difficult to work with in achieving consistent accuracy, and that led us to have to develop a custom processing pipeline. Another important step is to calibrate the camera's position relative to the robot. Since the camera is mounted some distance and rotation away from the center of the robot, we need to ensure that the offsets are calibrated correctly to avoid any systematic errors. So we measured with a ruler its position relative to the robot's coordinate frame, and then verified the calibration by moving the robot around the field and making sure that it was consistent with our odometry. Before we go into the code implementation, let's look at an example of our robot's relocalization in action. Now I'll walk us through the code implementation of our hybrid localizer. Since Pedro pathing already provides excellent localization with odometry using its follower, we simply wrapped its follower inside our own AprilFollower class, which allowed us to inject relocalization functions without modifying Pedro's source code. This is our class AprilFollower. Next, we created a Limelight subsystem class, which is responsible for handling all camera communication. And this class does the following functions. It initializes the Limelight, retrieves AprilTag detections, and then converts the Limelight's pose estimates into Pedro poses, returning them to our relocalization functions. And the way we trigger relocalization is using a state machine. When the driver requests relocalization, we will start collecting AprilTag measurements over a short period of time. And we basically clear previous samples and begin a new collection cycle, starting this buffering. So as the robot is collecting these samples, we need to be careful about robot motion. So if the robot is moving, that will introduce motion blur as well as changing viewing angles, which gives us really bad pose estimates. Therefore, if the robot is translating or rotating above our thresholds, we will abort the relocalization attempt. As we noticed from the large amount of variability in MegaTag1 pose estimates, we can't just trust the pose given by a single frame. Therefore, we collect multiple measurements from the Limelight up to 10, which in 40 FPS takes around 250 milliseconds. Now we will average the 10 poses. When averaging all 10 poses, be careful about averaging heading. This is because you cannot just add up the numbers together. For example, 359 degrees and 1 degree should average to 0 degrees, not 180 degrees. Therefore, we first average the sine and cosine components separately before reconstructing the heading with arctangent. After we compute a preliminary average, we might still have bad pose data. Therefore, we reject any outliers which are more than 10 inches away from the average result. Then we recompute the mean using the remaining measurements. And once we filter the samples and have our final pose estimate, we overwrite Pedro's current pose, and this becomes the new pose that is used in later follower updates. Here's some more considerations to improve your team's relocalization performance. First, consider mounting your Limelight at an angle relative to the AprilTag. If it appears slightly trapezoidal in the frame, this tends to reduce the pose ambiguity and give you better estimates. However, since the Limelight will be considerably below the goal AprilTag in DECODE, we have just achieved this effect by mounting the camera vertically. Also, ensure the lens of the camera is clean by wiping it regularly. The relocalization will also be more accurate closer to the AprilTag, but we have tuned our pipeline such that we have had no issues with relocalization from the far zone. Finally, make sure to watch our Limelight setup for FTC guide to learn how to optimize the camera settings for your AprilTag pipeline.